Welcome to the Funnel Reboot Podcast with your host, Glenn Schmeltzley. Let's get into today's show.
Artificial general intelligence is a term most of us have heard, a good number of us know how it's defined, and some claim to know what it'll mean for the average marketer. When asked about what he thought it meant, OpenAI's Sam Altman said this, quote, "It will mean that 95% of what marketers use agencies, strategists, and creative professionals for today will easily, nearly instantly, and at almost no cost be handled by the AI." Despite how sure he is, nobody knows for sure when artificial general intelligence will be here. Hey, Glenn here. Welcome to Funnel Reboot, the show for analytically minded marketers. Some said that GPT-5 would herald the dawn of artificial general intelligence. This episode is airing in mid-2025, and GPT-5 has come out, and it is not believed to have reached AGI. Our guest says that AGI is a long way off, and that it might not be the milestone needed for AI to be a revolutionary force in our lifetimes. Today's guest takes us through what it will take for AGI to truly arrive. We also talk about public versus private models, mixture of experts, the branches of AI, such as foundational versus generative, agents, and agentic workflows, which all need to be considered as part of this big picture. Our guest graduated from DePaul with an MBA, has headed the AI and analytics groups at Ernst & Young, Gartner, CSL Behring, and now at the Hackett Group. He's written several books and is here to talk about his fifth, which came out in 2025. Let's go now to Chicago to speak about the path to AGI with its author. Welcome back for the fourth time on this show, John Thompson.
Welcome back. John Thompson, welcome to Funnel Reboot.
Oh, Glenn, it's so exciting to be here. I didn't realize this is our fourth show.
You're the only person to have that distinction.
Yay.
We are going to talk about your latest book, which is called The Path to AGI. And I want to begin with understanding something because we have been bombarded in the media, particularly in the last 2-3 years, of talk of AI and this kind of end destination called AGI. But let's roll back before we get there and understand what you make clear in the book, which is there is no one AI. What do you mean by that?
That's a great way to start out. First of all, let's define AGI. Some people don't know what that acronym means, and that's artificial general intelligence. That's when AI acts and interacts as if it was as smart as an average undergraduate student or person. So that's when AI becomes sentient or conscious, or we think we're interacting with people and we're really interacting with an AI. Most people think, hey, I'm working with AI. Well, that's not really the case. You're working with some type of AI. We've had foundational AI for 70 years. We've had generative AI for 3 years. And we've had causal AI for 18 months or 2 years, depending on how you define when that came out of the research lab. So there's 3 families or 3 pillars of AI that people are interacting with.
We understand that these AI became possible with the advent of 2 things. Early computing experts started to look at this as being a possibility. They looked at biology, and then they looked at their early day computers and said, we think there should be some way to use the principles that biology has for thought and implant those into computers. But then the other thing that came along was this realization that there's a lot of information out there and that we had not tapped into a fraction of it. So first off, could you tell me what era are we talking about these computer experts? Are we talking like the day before yesterday or a little earlier? And what kind of data were they using?
It all really started out in 1956 at Dartmouth
Wow.
University. There were a handful of people, Claude Shannon, Marvin Minsky, a few people that were toying with the idea of going from autotama. Now that's hard for me to say. Automata. I have a hard time with that word. I'm glad we don't use it much anymore. They were working on electromechanical systems. And they thought there's got to be a way to build a computer. They thought in hardware and software terms that actually thought and learned from data. So if you go back to 1956 and look at all the principles of the Summer Dartmouth Conference, they laid out exactly what AI would become. And that's kind of amazing that in 1956, they would have foreseen and documented principles we have just realized in the last 10 years.
So now let's turn to the data. This podcast is about how business people, even marketers in particular, can use data, how it is important. You described data as being a primary enabler of what they were doing and that it will be core to what we do in the future. So take me back to those early computer experts. What kind of things did they think they could do with data to show that a computer can mimic a person?
Yeah, that's a great question. They were very much operational research people. They were looking at supply chains, manufacturing lines, sales productivity, and things like that. They were trying to bring together small amounts of information, single source generally, to look at it and say, how can we reduce scrap, on this manufacturing line? Or how can we make this production line that's making predominantly military munitions run faster? A lot of things in the early computing days were driven by the U.S. Department of Defense and military applications. It was great in that it jump-started AI and gave people a frame to think of, something concrete they could measure and improve.
One important thing about all of that data is it's structured data. In other words, numeric.
Yes.
Yeah.
Tables, columns, and rows that you see in spreadsheets every day.
Right. So relational data where it can be ingested. You also pointed out single source. That was the capability that most of those systems could do in the late 20th century. We're going to skip ahead for those interested in parts of John's book. He does even detail the time periods where very little happened in AI winters. But jumping ahead, one of the big steps forward was getting beyond single data source. And you yourself had witnessed this firsthand in some of the early and ongoing projects you've done, you say. What they all had in common was they ingested what was considered to be an impracticable number of data sources and a mind-boggling number of variables. That was hard to do, was it not?
It was hard to understand how to align the data. Data has a grain. Let's say I did an application for a brewery, globally recognized. Everybody knows this brand, and it's been decades, so I could say it. It's Anheuser-Busch. I was looking at sales data, distribution data. It's just different points in the distribution cycle. You're making it, you're shipping it, you're doing this different kind of things. So I was looking at that, and I'm like, okay, what are the things that impinge on the supply chain and what should change what we do? And I just thought, well, weather data, of course. People, when it gets hot, they like to drink beer. So I was talking to people and I said, I want to bring in distribution data, sales data, manufacturing, weather data, demographics, supply chain efficiency, retail, sales information. I want to bring all this together and predict where we should ship beer. And the guy that I was doing the work for looked at me and he said, kid, I don't care what you do. I was a kid at the time. So I was like, okay, that's tacit approval. So I went off and I got all the data, aligned the grains, integrated the dimensions, started running these models on it. I think they used it for like 10 or 12 years because it predicted where you should ship beer a week before it was going to be sold. And that was a big deal in the summertime when you have all these warm weather holidays. I think they got like 1% or 2% on their gross margin added to it just because the beer was in the right place.
Amazing. So what's happening behind the scenes is that the operational data they already had, plus external data, are being combined. What that is doing for the models is allowing them to see patterns which, I suppose, if you had a Nobel laureate or all the time in the world to study. You might find those yourself, but to a computer, it's a piece of cake. You are providing it with rocket fuel. Now, there's a part to this that we've got to think about, which is storage. When you take existing data sources and combine them, you're actually creating new data. And we live in an age where we haven't got permission, especially in a marketing sense, from our users. You wrote a whole book about how there should be limits on the data that is collected on us as private individuals. If there is going to be this data explosion, and it's not only complementary to AI, but integrated into how AI does its thing, what do we do to handle this data explosion?
Yeah, that's a great question. We have massive supercomputers. Most people on their desktop have more compute power than I ever did in the 80s when I was starting out as a data scientist. We have large data centers, lots of disk, lots of memory, lots of compute, all the infrastructure's there. It's just a matter of affording it and putting it together. Not everybody, but even small companies can do this. Medium-sized companies, family businesses can do this. So it's not so much about the compute infrastructure. It's more about understanding that we've gone beyond structured data. Structured data is 10% of the world's information.
When you talked about foundational AI, that's just using that 10%. That's all
All it works on is foundational AI. Then as we move forward, the structured information is 10% of the world's information. We usually downsample it and are working with 1% of the world's information. Now with Gen AI, we're using 100+% of the world's information. So we have to stop and think. That's mind-boggling. We had a hard time dealing with 10% and we reduced it to 1 to make it easier. Now we have 100% that we can work with because we're creating new data and bringing in synthetic data generation. You brought up the idea of permissions and making sure you have permission. A lot of companies, it's very hard to get permission because you're thinking of new use cases all the time. If you look at GDPR and many of the personal protections in Canada, Australia, across the EU, you have to ask permission for every new use case. That's impractical. In marketing, you come up with a new use case almost every day. You can't go back and ask everybody every day. It just doesn't work. So you can actually look at the data and synthesize it. You can create new data that has no connection to a natural person or a company. We have the ability to create massive amounts of information that's disconnected from anything in the real world.
You say that the thing that we can be starting with, no matter where we are right now, is that we can be collecting and storing the data that we have. I'm not asking for any budget here, so long as it's within regulatory boundaries. If you need to, synthetic data can be created out of that. Let's return to that tipping point where we got to generative AI. You actually described, and I thought it was a very honest and pivotal moment in time for a lot of people when those early computers were around. If anybody's read any Malcolm Gladwell, he talks about Bill Gates. He talks about how Bill, as a teenager, had the chance to sit in a room, I think in the University of Washington, and get his hands on a supercomputer. At that point in time, there were some computers. Even if you don't know that example, most people know the story of like HAL 9000, right, from Arthur C. Clarke's 2001, said how it was created at the University of Illinois, Urbana-Champaign, and that it was one of the most powerful computers of its day. You got to sit in a room in an IBM facility, which many think that HAL was a reference to IBM, that had a neural network utility. Tell us about that and tell us how that changed your career.
I've been working at IBM for a while on large databases, business intelligence, advanced analytics, and statistics. I kept saying to people, we need better analytics, more powerful analytics. They said the research group has written this thing called the Neural Network Utility version 1, and we want you to test it. And I wasn't the only one. There were other people as well, but I was the only one in this facility. They flew me up to Rochester, Minnesota in February, which is generally not a place you want to be. Kind of cold. You're in Canada. You know how it is in February. I sat in that room for nearly 2 weeks and banged on that piece of software to get it to find out what it could do. I could train it. I could get it to do things. I could build models. I could do all sorts of things. I was using a PC, the first PC that had a hard drive. So I didn't have to keep flipping in floppy drives. But it was an awakening moment for me that there was software that could learn. I was creating synthetic data in a spreadsheet, running it, seeing how the model would change. And then I would create more data and run it in and see how it would change. And I looked at it and I said, boy, this isn't very useful from a practical perspective, but I can see this is the beginning of what is going to be a massive change in how we do analytics. That set me off on a new path. I had always been involved in data, analytics, statistics, but now I had my teeth into AI.
Perfect. This kind of takes us into what those branches of AI that you spoke of are doing. The neural net, which is basically a chance for a computer to learn, but also second guess itself on the learning and run through several iterations of learning. Foundational AI continues to use that. It's used for everything from what Netflix show to recommend next to what order to land planes in. And yet, you say that foundational AI, which is kind of an umbrella for a whole bunch of things, but neural nets are a big part of it. That's disappearing into the background, almost like the plumbing or the electricity.
That's right.
It's not going to be seen by us, but it's still very much there. Now, that the same kernel that enables foundational AI, those neural nets, has been repurposed into generative AI. Take us through that.
Yes, exactly. Foundational AI is a broad term for many different approaches, and neural networks is in there as well. It's a big part of foundational AI. Now, Amazon, Google, Microsoft, OpenAI, 6 years ago, they were really banging on neural networks, trying to come up with something different. Google wrote the paper, Attention is All You Need. And that was really the beginning of what we know as Gen AI. So most people think of Gen AI as its own pillar of AI. But really, Gen AI is a subset of foundational AI. Gen AI is based on neural networks. And the difference was that Google had done this well before OpenAI did it. They took basically the entire content of the internet and jammed it through a neural network. It proved what I had been saying for years. It's not that neural networks are magic or do something unexplained. It's when you get data at scale, different things happen. Back in the 80s, when I was doing the Anheuser-Busch application and different kinds of sales and marketing application and bringing together 10, 15, 16 different data sources, which was hard to do. Now we've taken it to the point of unstructured information. We don't have to do all this alignment and integration. We just have to take it out and jam it through this neural network, and we get generative AI. We're now 3 years into generative AI and about a year and a half into it. There were well-respected computer scientists and technologists saying these things have emergent behaviors. They're doing things that are different. They're finding out things, they're thinking, they're creating new knowledge. And that's not true. They are not doing that at all. When they're trained on a massive amount of information, it's very hard to predict everything it's going to do. One of the things that will further our conversation here is that if you jam the entire internet through a neural network in generative AI, you inadvertently pick up all the rules of causality. So some people think, oh, Gen AI, it's amazing. It does causal AI. It doesn't do causal AI. The only thing it knows is it has all the rules of causality that inadvertently were put into it. So it can do things around causality. It can't do causal AI. The one thing it really does well is it gives you good causal pairs. X cause Y. And that's something that humans really have a hard time doing. So causal AI has been held back because people can't feed it the right information, but Gen AI can. So now we see interleaving of the pillars of AI. Foundational AI, neural networks started there. They created Gen AI. Gen AI does really good causal pairs that feeds causal AI. You can see the glimmers of how these things are going to start to come together.
Right. And on causal AI, you've written a whole book on that. I'd refer listeners to the show notes where we did an episode on that. It is a pillar, as you say, unto its own right. And yet there's a couple other things that we need to demystify around generative AI. I think one of the things that you've done very well is you've pointed out one of the big breakthroughs of this was the most simple aspect, which was that the developers who were putting the experiment out at OpenAI decided not to give it a regular interface. We've been used to a search box. We've been used to the computer coders interface.
Yep.
Decided to give people a chance to chat with it, as the name suggests. That turns out to be a hugely important thing because that allows it to understand the prompts. So let's talk for a second about what it's actually doing so that people who are doing marketing with it, for example, are not confusing it with a search box and are not confusing it with intelligence that can actually help solve every marketing problem they have.
Absolutely. The prompt window, the natural language interface is a brilliant invention, and kudos to OpenAI and Google and all those people for thinking about it. As you say, Glenn, there's a fair amount of people, and they tend to be a little older. They tend to use it like a search engine. What's the capital of Ontario? What's the center of Africa? Well, these are just facts that are searched. The prompt window is something more than that. You can actually put in context. You can put in instructions. You can put in language. And many people, tend to think, and we do some way, we're biased a little bit in this direction, is that we always say, oh, well, you can use English. Well, of course you can use English, but it is natural language. You can use Hindi, Urdu, Tamil, French, Dutch, whatever language you speak, there's models out there that actually ingest natural language and speak to you. You can speak in, let's say, French and have it come out as Dene, a Native American language. So you can have two people that can't speak to each other speak through a model. You type in your language, it comes out their language. They tap in their language, it comes out your language. It's pretty cool.
It's doing that through, right? It tokenizes the language.
Yeah.
Tell us how that works. By the way, I'm going to include in the show notes an amazing tutorial from the Financial Times.
Yeah. So when you type in your language, whatever natural language it happens to be, the first thing the model does, or the prep for the model, is it breaks it up into tokens. So I always talk about Mary had a little lamb. Most people have heard it. It takes Mary and little and turns it into a token. Had a turns it into a token. Lamb into a token. It breaks it up into these tokens and then ingests it into the model, runs through the model, and then the model generates new tokens and comes back. If you typed in Mary had a little lamb, it would probably come back and say its fleece was white as snow. It predicts what are the next letters, words, and sentences that should come back. That's really all a large language model does. It predicts what should be next. What letter, what frame of graphics, what code snippet. It predicts because it's been trained on a massive amount of information. It gets tokenized, runs through the model, gets a result, gets tokenized, turned into language, and sent back to you.
Yeah, that's a lot in a fraction of a second. And that attending that it does, where we get the self-attention idea, taking that set of tokens and going, what seems to be the subject, verb, or object of the sentence? We might be talking about a farmer named Mary who has lambs on her farm, not the famous poem. So it's got to look at that and go, where else in the corpus of all this unstructured data?
It's really good at it. Most people think this stuff just came out of the blue. Nothing just comes out of the blue. I've had teams working with natural language processing, natural language generation, natural language understanding for at least 6 years. They took these large neural networks and did something different with them, which took the innovation curve from this to that. Yeah. The understanding of natural language has been around for quite some time.
This is important. Marketers are saying to themselves, how can I use this stuff? I want us to go through a couple of things that still happen, both from those pioneer model companies, but also things that we should be doing in our org for us to have a successful implementation that involves Gen AI. We're not there yet. So there's this thing called grounding, and it must be done with these models for the output that it's giving us to be better than gibberish. You also mentioned that we need to know the people that are building these models, at least the big ones, are trying to do it all people. And that's not the only kind of model. Take us through a couple of more specific models. People may not realize that these public models are just one type of model that you can have.
Yeah, there's all sorts of large language models out there. There are proprietary models from OpenAI and some from Google and Amazon. And there's open source models from people like Meta, the Llama family, and Mistral. So we have open source models. We have proprietary or closed source models. In the last couple months, we've augmented the idea of large language models with large reasoning models. Now we're starting to see differentiation in the large X model family, large language models, large reasoning models, large action models. One of the things that we want to make sure that we communicate, you and I communicate, Glenn, is that most people think when they're sending in a prompt via a prompt window, they're prompting a model. That's really not the way it's working anymore. It's generally an ensemble of models that they're prompting. So what they're doing is they're sending in a prompt to an orchestrator model that has been trained to understand all the other models behind it. The orchestrator tears the prompt apart, sends it to various models. Those models respond, send back responses. The orchestrator recombines all the responses and sends you a combined response. So we're really not using a model anymore. We're using an ensemble of models.
MOE is another phrase I've heard. Maybe that means the same thing, mixture of experts.
Mixture of experts and an ensemble is the same thing.
So that's what's happening behind the scenes. Those models, be they slaved to one domain. For example, Anthropic has one that's particularly good at writing code. Some models are particularly good at image creation. We need to understand that different models are being used behind the scenes. You can sometimes specify what model you use. But one thing you're going to get, no matter which model we're talking about, is a probabilistic result. You talked about a GPT created movie around a person named Brian Eno and how it basically spawns a slightly different movie every time. Anyone who does an image creation on Midjourney or on ChatGPT will notice the image doesn't come back the same each time. This is something we need to align our expectations on. Is the model broken, or is this just the way it is?
Systems like marketing management systems, customer relationship management, and enterprise resource planning, those are deterministic systems for the most part. If you run a query and it's 2 plus 2, it's going to come back as 4. That's just the way those systems work. Now we've moved on into probabilistic systems. Neural networks are all probabilistic based. So if you run a prompt or ask it an image to be generated, the response is going to be different each time because it's predicting what it thinks is right. And whatever is right in that time is going to be different. So it's going to move the unicorn to the right, or it's going to move it up. Or instead of the unicorn being white, it's going to be purple. It's going to do different things because it thinks that's the right thing to do. And generating text is the same thing. So if you send in a prompt and you say, I have Mixtral 7B, I have an OpenAI model, and I have a model in the Bedrock family, I'm going to prompt each one with the same prompt. The information is going to come back, and when you read it, it's going to be different. One's going to be more terse. Another one's going to be more collegial. Another one's going to be more formal. We are in a probabilistic world, and it never comes back. In the early days of large language models, if you ask it what 2 plus 2 was, it came back and said Wednesday.
Or how many R's are there in strawberry?
Those kind of things. It's one of those things that your mileage may vary. The results are going to be different. And sometimes that's very hard for people, like auditors and engineers tied to precision in the answer. It's hard for them to get their head wrapped around that sometimes.
You've described almost every boss or decision maker at a client. We got to tackle this head on because you say that companies should be undaunted about trying a proof of concept, getting something prototyped. But the mistake that we tend to make the most is if you've undertaken a proof of concept with any emerging technology and you learned how to make that technology a productive part of your operation, and then you take those learnings and begin to plan for improvements in processes around it to obtain those perceived benefits, that may be considered a failure of the project. Not at all a failure of the project.
You've taken something that you had no understanding of whatsoever and figured out how to make it work in your environment. Now, maybe you applied it to clustering, classification, forecasting, and you got a bad forecast. That's okay. That application was probably not appropriate for the model you were trying, but you learned how can work for your organization. This narrow view that I have to get improvement in every project, even early stage proof of concepts, I think that's very short-sighted.
The easiest solution is to do nothing. If we look at historical examples, it might be more apparent where this separation between what tech can do and what our existing infrastructure is like. When I read that, it took my mind to things like telegraphs, electricity generation, municipal water systems, or mobile cell phones. If we built one of those on a lab bench, but didn't have the wires, pipes, or towers, we would look at those and say, those devices are failures.
In the early days of electricity, until we reconfigured all the factories to take advantage of electricity to run all the different motors that you could put in place, electricity was a failure.
So we need to think about generative AI the same way, because without fine tuning what we have internally, there are limits. We also need to fine tune how our company can implement these technologies. But let's pause for a second and remember, compared to foundational AI, there was always another person. I'm going to mention another book that you wrote, Building Analytics Teams, where you had to take us through how data scientists should be organized and work alongside of business users to get any kind of technology. And here we are, not that long later, and now you're saying in this book, this technology allows a business person to directly get the output that they want, or maybe a draft of it. There's no intermediary.
One of the things I want to make sure we get our heads wrapped around is that we talked about data integration and the Anheuser-Busch example and how hard it was. The integration of data into a large language model can be done by anybody. You don't need a data scientist. You don't need a data engineer. You can bring these things in through easy to use tools, integrate it quickly, and get results almost instantaneously. Some people are saying data scientists are dead. We don't need them anymore. We have an AI group. We have a data science group. You're getting way too far ahead of yourself. We do need data scientists because we need foundational AI, and you don't know how to do that work. They do. The data science group and the AI group should be one group working together to bring these things forward. There's plenty we can do with Gen AI that end users can do, but there's plenty of things that need to be quality checked too. Just because you let an end user loose with a prompt window and data, I don't think you want them doing marketing offerings willy-nilly.
Creating landing pages.
The example, I think it was Air Canada, where they offered airfare for like a nickel or something like that. I don't think they want people doing that. Mistakes still can be made. So we still have to have quality. We still have to have collaboration. We still have to have subject matter experts working on this stuff.
Very true. We talked at the very beginning about artificial general intelligence. And here we are. So we're recording this in mid-2025. There are articles in the press. I think you use the word hucksters to describe them, who are using to sometimes help their own business make a buck, but also to get people really riled up. What is the prediction that they're making that grates on you about AGI?
These people have a dog in this fight. They're raising billions of dollars for their company and trying to profit off it, which is fine. I'm a capitalist. I have no problem with that. But I don't like it when people are being misled. People like Elon Musk and Sam Altman and Ray Kurzweil, they're all saying AGI is here today, or it'll be here in 6 months or 6 weeks or whatever it is. That's not true. That's just not true. Large language models are not the path to AGI. It will never be the path to AGI. Just being able to predict another word or a sentence or the right paragraph really denigrates human intelligence. We are so much more than that. And what they're saying is AGI is the equivalence of human intelligence. So we're a long way away from that. In my prediction, let's just put it out there to be clear, we're 123 years away. And I get grief because that number is so specific. I went back and I looked at the last 70 years. I dissected our progress and I looked forward and I looked at quantum computing. I looked at discontinuous innovation. And from what I can tell, from my learned opinion, we're well over 100 years away from this happening. It's an incredible jump, in my opinion, to say that you can predict the next letter or word and then in the next breath say that you're going to have an AI that I can talk to that has the same kind of relationship interaction that you and I have had for the last 45 minutes.
Right.
I don't think that's anywhere near that. Just like when you started this program, you said, "Hey, John, welcome for the 4th time." That's memory. That's relationship. That's human intelligence. You go and talk to any model, any large language model, have a conversation, have an interaction, and then leave and come back tomorrow. It doesn't
Right.
remember you.
It's amnesiac. Right. You point out a dozen points to what the definition of AGI should be. One of them being that infinite context window of, I want you to remember back to the very first time we even interacted on any platform. That's a
Anywhere,
tall order.
any day.
Another part of it that I want us to focus on is that the AGI should also understand that relationship to the point where it puts itself into a safe mode when it isn't abiding by the rules placed on it by humans, and that it gives a transparent account of when it even flirted with doing something outside of its given boundaries.
That's right. Most people are not understanding that large language models have something called a system prompt. A system prompt is about a 50-page prompt. And whenever you put in a prompt and send it, the system prompt is appended to that. So that system prompt has things like don't bring up Nazis, don't be anti-Semitic, don't be sexist, don't tell people how to build nuclear bombs, all those things. And that's just a set of rules of basic human decency. What I say we really need is the user prompt, we need the system prompt, and we probably need an additional intermediary prompt. Like, Glenn, you're going to go do some work for Air Canada or Tim Hortons or whoever you're going to do work for. And you have a 25-page prompt that are the rules that you abide by. You should have the prompt to do something around this campaign or classification, clustering, or segmentation. You have your rules of the road. You have the system prompt. You run all that and it comes back and everybody thinks it's just like magic. Well, no, you set up all the rules in the right way for it to act the way you want it to act.
And so you're saying that there will have to be, you mentioned orchestration, but you even argue that there has to be at some point a composite AI that will take this on.
That's right.
Why you have some faith in your very long time horizon is you imagine it might take us as long to get to a good composite AI as it's taken us this entire time just to get to today.
That's right. I've looked at it very closely. As I said in our earlier remarks, we see glimmers, interactions between foundational AI, generative AI, causal AI. Soon, we're going to start to see more developers and really bright data scientists bring these things together. At some point, software companies are going to say, hey, I've got a really great LLM and I'm going to integrate causal AI or foundational AI. They're going to do that. But it's going to take another 30 to 40 years for that to happen. And once we have composite AI, then we can start driving it forward with memory and context and emotions and psychological intelligence and all the other things that we have in our wetware just don't exist in computer models today. So It's going to take a long time. I think people really don't appreciate the value and the multifaceted nature of human intelligence. When you talk to people and they say, hey, let's talk about intelligence, I'm like, okay, what little part do you want to talk about? We could take this itty bitty piece and talk about it for the rest of our lives.
Right.
So talking about intelligence that's a pretty daunting task.
Look at the sum total of human knowledge we've accumulated that after you think about that, you don't want to cheapen what intelligence is because none of that was here until we started banging one stone against another and sharpening it.
That's right. Absolutely true.
Now, one stopover that you do highlight and you say, because some people might hear this and go, well, if I'm Glenn's or John's age, this is well beyond my lifetime and there won't even be an appreciable amount of progress. Not so. You point out that right here and now, we're seeing the dawn of a stopover technology, I'll call it, agents. How do agents help us very quickly in the next short-term horizon?
Yeah, agents and agentic workflows are incredible. We're taking large language models and Gen AI and foundational AI, causal AI, we're leaving them in the infrastructure and putting agents on top of them. And agents help us in many different ways. They allow us to book airfare, book hotels, bind to contracts, spend money, evaluate different documents, and evaluate the quality of videos and things like that. So agents are here today. We've built many simple agents. We've built some intelligent agents. And even last year, we built some polymorphic agents, agents that will build themselves. So all you have to do is give it an objective. It's really cool. I do get people pushing back on me and saying, oh, you're an AI Luddite, that you're saying there's nothing here. And I say, no, there's plenty here. I'm so excited that the rest of my career, for however long it will be working on leading edge, really hard things to do. I want to do stuff that's hard. I want to move human intelligence and artificial intelligence forward in an appreciable way. But I have a great appreciation for how far away we are from human intelligence. So I'm trying to be a pragmatic voice of reason. That if you're really smart and want to work on hard problems, jump in the pool. There's a lot to do.
So let's say we dive into the pool. I'll ask you if you can think of use cases in the near term or even when AGI is here, I'll let you choose, of how the acquisition of customers, sales and marketing being changed by AI.
How frustrated are we all by interactive voice response and that we can't get to a real person? I do believe agents can make that better. Customer service can be better. I know lots of companies that, you do get to a person and that person can't interact with as many humans as possible because at the end of the call, they have to take 35 minutes or 40 minutes and write up the entire dialogue. AI is taking care of that. You have the interaction, help the customer, make them happy, get them to a point of joy, stop the call, and you immediately have a transcript of everything that was said because that's an agent and an AI model doing the transcription for you. So you spend 4 minutes falling through it, 5 minutes, 6 minutes, 10 minutes, whatever it is, and saying, yep, that's right, save, or no, that was a little messed up. They said 8 and it put in not the number 8, it put in 8 as in you ate something. But you fix that up and then you save it and you move on. It's a
Right.
great productivity tool for customer service. It's a wonderful tool for having people interact with your company, even if you don't want customer service manned by humans. Agents are really getting to the point where they're dynamic. They understand people's tone and demeanor. They understand when people are frustrated. They can change their behavior and the way they talk to people. I think agents and large language models are here today making a difference in marketing.
I'm hearing clearly you're saying that we as humans have a big role in supervising and training.
Agents can't do anything without us. Models can't do anything without the data we feed it. If we want to build a model that's mean to everybody, we could do that. That's not very nice, but we could do it. If we want to build a model that's empathetic, has time for you, and will work through your problems, no matter how many iterations you want to do, we can do that too. There's a company, they serve predominantly senior citizens. What they did with their models is they just made the models pleasant. Hello, please, thank you, you're welcome. That kind of dialogue goes down really well with that demographic. Their customer satisfaction ratings went up by 12 points. When they took out people, they put in models that were consistently nice.
There's a lot that we can do, and customizing, one might even argue, doing marketing and sales on a one-to-one basis become possible. You are not diminishing how transformative AGI could be. You're saying also,
It'll be massive.
in the meantime, we better think about getting our regulatory house in order, getting an understanding of the roles that humans have in training and supervising. We have a lot we can do.
We have a lot of work to do at the supranational level, like the EU, the national level, like Canada and the United States, Australia. The regulatory environment needs to change completely. We need to understand what we want these models to do, what we want artificial intelligence, how it interfaces with human intelligence. And we have to figure out how we as a society or societies or a civilization are going to accept and govern AI.
Yeah.
Because, there's I think it was AI Shipley that I think I got the letters wrong, but I think in the 60s, Shipley talked about, an ever learning AGI that learns every second and got smarter and smarter and smarter and smarter. I'm not sure that we want that. I'm not sure that's something we're interested in. We could have it. And if we had it, would that be a good thing? And I think most people don't really think about those concepts and consequences. They look at Space Odyssey and they're like, oh gosh, that's
Don't
really
want that.
scary. Yeah, well, that's pretty simplistic. If you had something that was learning every second and getting smarter and smarter, that's really problematic.
The point I got from your book is we get to choose, and we need to assert ourselves and ask those questions and point back at ourselves and say, okay, so what's the answer?
Our answer. Because we can't ask the AI to give us the answer. We have to have the answer.
So there's certainly a part that we're going to play. And I think I've got a much clearer sense of what the path to AGI looks like after reading this. John, if people want to get their hands on the book or find out more about what you do and where you do it, where can they go?
The books, all 5 of them are on Amazon. So that's a place I point people for purchase. I'm on LinkedIn almost every day. Look up John Thompson Analytics in Chicago. If you're in the data and analytics space, connect with me. I'd love to have an ongoing dialogue with all of you.
For our listeners for figuring out how we can get farther along in this field.
So glad to be here for the 4th time. Can't wait for the 5th.
Thanks, John.
Thanks for listening. Follow the show on Twitter @Funnel Reboot. If you like what you have heard today, please consider leaving a review wherever you get your podcasts.